Okay, here we go. Some extra practice for those looking to get in a little bit of extra review. I've picked 2 of each type of function for graphing. I also created 2 composite functions where you are creating the composite function. The reason there are 2 is because for each of these, my recommendation to you is going to be that you pause the video initially, because this is a review, it's not me teaching. So like as soon as you're ready to start this first one, pause the video, give it a shot, see if you can graph it, and then start the video when you have either gotten stuck or when you have an answer, so that you can see how it's done, hear an explanation if that's what you needed. I picked 2 because for some of you, you might feel really good at the end of the first one and then maybe want to skip on to the next function. Then go ahead and do so. But for those who maybe got a little bit tripped up the first time through a particular function, you'll have a second one so that you can try again on the next one. Okay, so here we go. Again, pause the video, give it a shot on your own, and then restart when you're ready to hear how this one is graphed. Okay, so turning this into descriptive form, let's go ahead and subtract that 4 to the other side. We have y minus 4 equals negative 2 times the quantity of x minus 7 squared. Okay, my initial point, my vertex is going to be at x equals 7, y equals 4. So positive 7 and positive 4. So let's go ahead and graph that. Positive 7 and positive 4. Okay? And then because this is a quadratic, we need to make sure we're thinking a over 1 and only a over 1 for the first time, right? We don't keep doing a over 1 indefinitely. So my a is negative 2. So we are negative 2 over 1. So let's go down 2 over 1. And then you don't keep going down 2 over 1. This is quadratic. It's not linear. So that pattern doesn't keep going because a quadratic, remember, is curved. Okay? And so we're going to go ahead and be able to curve this function and create our u. Now, if you wanted to plug in some other values to kind of check what you've done, you're more than welcome to do so. I'm not going to for the sake of this video, but the next time you're in class, if you would like to kind of work through some of that with me, I'd be happy to do so. Okay? Okay, go ahead and pause the video, give this next one a shot, and restart it when you're ready to go. Okay, so turning this into our descriptive form, we have y plus 6 equals 1/3 times the quantity of x plus 5 squared. My initial point, my vertex, is at negative 5, negative 6. So let's go ahead and plot that. Negative 5, negative 6. Okay. And then we're going to be going a over 1. My a is 1/3. So this is up 1/3 over 1, which is going to be pretty spread out there. Okay? And then you've got your curve. Okay, next up, we've got some absolute values. Go ahead and pause the video, give this one a shot, restart it when you're ready to go. Okay, so here we go. We have y equals 4 times the absolute value of x minus 3 minus 5. Let's go ahead and turn it into our descriptive form. Y plus 5 equals 4 times the absolute value of x minus 3. My initial point, my vertex, my x is going to be positive 3, my y is going to be negative 5, and then my slope is 4. So here we go. Positive 3, negative 5. Slope of 4, so I'm going up 4, 1, 2, 3, 4, over 1. And I'm doing it in both directions. Now this one I could keep going because this is a linear absolute value, so that pattern could persist if I wanted it to. You do not have to keep going though. You can stop with those two values if you would like. And so we've got our absolute value. Okay. Next one, go ahead and pause the video, give this one a shot. Okay, descriptive form, let's go ahead and subtract that 2 over. And my initial point, my vertex, is at x equals 0, y equals positive 2. My slope is going to be negative 1/5. So let's go ahead and plot our vertex at 0, 2. And then a slope of negative 1/5 means down 1 over 5. Down 1 over 5. And I've got my absolute value. That V shape. Okay. Next function family. So we've done quadratic, so squared creates that U shape. We've done absolute value, creating the V shape. Next up, we've got our exponential. X in the exponent of exponential. So go ahead and pause the video, give that first one a shot, restart it when you're ready. Okay, descriptive form, let's go ahead and subtract that 2 over. And my initial point here is x equals negative 4, y equals positive 2. Now, because this is exponential, that is not actually a coordinate point on my exponential function. That negative 4, 2 is showing my asymptote. So here we go, negative 4, 2. Got an asymptote there. And then you have to plug in 2 values, or 2 other values. It's your choice what 2 you've plugged in, but as we've talked about many times, I recommend plugging in at least the negative 4 as your first one. So y equals 3 to the negative 4 plus 4. Because that gives me 0 in the exponent, and anything to the 0, 3 to the 0 is 1. 1 plus 2 is 3. And so I can plot a point at x equals negative 4, what I plugged in, and 3, what my y equaled. And then at least one other point, I recommend not going too far from this negative 4, so I'm going to plug in negative 3. Y equals 3 to the negative 3 plus 4 plus 2. Plugging negative 3 in here. Negative 3 plus 4 is 1. And 3 to the 1 is 3. 3 plus 2 is 5. And so my second coordinate point is at x equals negative 3, what I plugged in, and 5, what I got. And you've got your exponential. Okay. Okay, go ahead and pause the video, give this next one a shot. Restart it when you are ready. Okay, descriptive form, y plus 5 equals negative 2 times 1/2 to the x minus 3. Initial point is x equals positive 3, y equals negative 5. Again, that's not actually a coordinate point on my graph. That's a point showing where my asymptote is. So we go 3, negative 5. Okay, and then you have to plug in 2 values. I recommend plugging in at least 3, because that's the y value you already have. So y equals negative 2 times 1/2 to the 3 minus 3. Okay, when you simplify that, we get negative 2 times 1/2 to the 0, which is 1. Negative 2 times 1 is negative 2, minus 5 is negative 7. And so my first coordinate point is at x equals 3, what I plugged in, and negative 7. And then you have to plug another one in. Again, I would not recommend going very far away. So since you plugged in 3, I'd be plugging in either 2 or 4. We've talked a couple of times in class about the advantages or disadvantages to both. Again, it is your choice. You cannot go wrong. Advantage for plugging in 2, as a reminder, is if I plug in 2 here, 2 minus 3 is a negative 1. And think about what a negative exponent does. It spins this fraction. So if I plug in 2 and get negative 1 in the exponent, this 1/2 becomes 2. And you might like doing negative 2 times 2 minus 5. The advantage of 4 is if you plug in 4, you get 4 minus 3, which is a positive 1. And a positive 1 exponent is pretty friendly, right? A base to a 1 exponent is equal to the base itself, just like we did over here. When I got 1 as an exponent, 3 to the 1 was 3. And so you might like getting 1/2 to the 1, because 1/2 to the 1 is 1/2. Again, it's your choice. I'm going to plug in, you know what, I'll plug in both for the sake of this video. Again, you only have to plug in 1. You can fast forward the video if you'd like to. Negative 2 times 1/2 to the 2 minus 3. We already talked about the fact this would be negative 1, and so it would cause the 1/2 to become 2. So we have negative 2 times 2 minus 5. Negative 2 times 2 is negative 4, minus 5 is negative 9. And so this coordinate point, when I plugged in x equals 2, I got negative 9. Okay. If I instead chose to plug in 4, I'll do that up here. Y equals negative 2 times 1/2 to the 4 minus 3 minus 5. And we already talked about this. 4 minus 3 is 1. 1/2 to the 1 is 1/2. Negative 2 times 1/2 is negative 1. Minus 5 is negative 6. And so when x is 4, y is negative 6. And so whichever one you do, you still get your exponential curve. Okay? Okay, piecewise. Go ahead and pause the video, give this piecewise a shot, restart it when you're ready to check your answer. Okay? So this one's a 2-part piecewise, so I'm going to go ahead and give myself a little section here. Okay, first one, we have negative x plus 1. Y equals negative x plus 1. Turning it into my descriptive form, we have y minus 1 equals negative x. And so my coordinate point, pulling that out, my x will be 0, my y will be positive 1, and my slope is negative 1. Now, as I graph this, the only part of my function, of my linear function here that's going to show is what happens at less than or equal to negative 2. So I know I'm going to have a point at negative 2, and then I'm going to keep going left of negative 2. So you have a choice you have to make here, because unfortunately my starting point of 0, 1, since x equals 0, it does not make this statement true. 0 is not less than negative 2. I can't actually plot that point. Now I could really lightly sketch it initially if I wanted to help me with my graph, but I would need to make sure that eventually I erased it, because the only part of my linear that is showing is what's less than or equal to negative 2. Okay? Your second choice, besides like doing a light sketch and then erasing, is you could just start at negative 2 if you wanted to. You could plug in negative 2 and see what you get, and then maybe plug in negative 3, because that would be the next number less than negative 2, and see what you get, and you can come up with a sketch that way. It's your choice. For me, I'm going to go ahead and kind of adopt a little bit of that lightly sketch. Now I'm not going to be able to lightly sketch because I'm working with pen, so I'm just going to kind of point at where I would sketch. So if I plotted my first point at 0, 1, that would be here. And then if I did my slope of -1, I'd be going up 1, left 1. That would put me here. But again, I don't have a point there. And then if I were to do that again, up 1, left 1, my first point is actually here at x equals -2. For those who are plugging in, if I plugged in -2, negative times -2 is +2, plus 1 is 3. And sure enough, you can see at +2, 3, I've got my point. And then you can keep that pattern going if you'd like, so that you can get your linear. Okay, second one, x squared minus 2, or y equals x squared minus 2. Okay, this one is not going to start until, I just realized I showed this as a hole, but that's a point. This one's going to be a hole. This one doesn't start till -2, and it will be a hole at x equals -2 because there's no equal sign. Okay, adding the 2 to the other side, we have y plus 2 equals x squared. So initial coordinate point, x is 0, y is -2. And then my a over 1 is going to be 1 over 1. Okay, and so 0, -2, which is here. And x equals 0 is within this domain, so I'm going to plot that confidently. And then I'm going to go up 1 over 1. And I've got my quadratic. Now if you want to know where you're ending, because remember I should have a hole at x equals -2, so if you're wanting to know where you're ending, take this -2 and plug it in. -2 squared is 4, minus 2 is 2, and so I know I'm going to end, here, let me write that. Plugging it in, -2 squared is 4, minus 2 is 2. So I know I'm going to end at x equals -2, y equals 2. Right here. Oops, curve out that u a little bit, sorry. There we go. Okay. And then you're going to go ahead and do the next one. So we have our g of x equals, go ahead and pause that video and give it a shot when you're ready. Okay, this one's a three-pronged piecewise. Okay, first part, our 2x minus 4. Let me go ahead and separate my work here, so make sure we don't get it mixed up. Okay, our first part is our 2x minus 4. Y equals 2 to the x minus 4. If I added the 4 to the other side, we'd have y plus 4 equals 2 to the x. Okay, my coordinate point, initial coordinate point, x is 0, y is -4. And that's going to be my asymptote. Okay. And then you have to plug in 2 additional values. Okay. You can plug in 0, and you can plug it in confidently. 0 is within this domain. Because there is no equals here, I know I'm going to have a hole at 2, and then I'm going to be plotting everything less than 2. So if I plugged in 0, my x equals 0. 2 to the 0 would be 1, minus 4 is -3. And then you can technically plug in any value you want for a second point, but remember what we talked about in our notes for 1.3, which is where this comes from. It's handy to plug in this 2, because it gives you that kind of end point. You know that you have a hole at 2, and you know that you are stopping at 2. And so it might be handy to plug in 2 as your additional value. If I plugged in 2, 2 squared would be 4, minus 4 is 0. And so as I know as I sketch in my exponential function here, that's going to pass through that point and hit my hole. So something kind of like that. Okay. Second one, y equals x squared minus 5. Okay, adding that 5 over, y plus 5 equals x squared. My initial point is x equals 0, y equals negative 5. Now I can't actually plot that point, unfortunately, because 0, negative 5, x equals 0 is actually outside of the domain that goes with this function. I can sketch this point though if I'd like. I just need to make sure I erase it eventually so that the only part that's actually showing for this function is what happens between 2 and 3. Also make sure you take note of the fact that there's an equals, so we are a point, and another equals, so we are a point. Your other option, if you don't like that sketch, is what we've talked about several times now, starting back when we were learning this in the lesson, but then also on the previous example problem we just did, which is your other option is you could plug in 2 and plug in 3. See what you get, plot those points, and connect those 2 points. Because these are so close together, that might be worth your time. Okay? I didn't model that on the last one, so let me model it on this one. If we plugged in 2, 2 squared would be 4, minus 5 is negative 1. So now I know I have a point at 2, negative 1. If I plugged in 3, I'd have 3 squared, which is 9, minus 5, which is 4. Now, my word of caution for those who like this strategy, careful that you remember to think about what you are graphing here. Because the nice thing about this strategy is it gives you 2 concrete points. The unfortunate thing about this strategy is it's really tempting to want to connect these as a line. Okay? But remember what you're graphing. This is a quadratic. Quadratic isn't a line. There should be a slight curvature here as you connect it. Okay? Creating that U shape that I know I will have. Now for those who are sketching, if you were to come down to 0, negative 5 and plot a very light point right here, if you were to graph your quadratic from that point and use that to help you sketch, you are more than welcome to do that. Again, just make sure you erase everything up to 2, because that's where my quadratic starts for this particular piecewise. Okay, and then last but not least, we have y equals 4x plus 1. Okay, descriptive form, subtracting that 1 over y minus 1 equals 4x. My initial point is 0, 1. Again, unfortunately, I can't plot that one. X equals 0 is not inside of my domain for this function. But I could really lightly sketch it if I wanted to. And then my slope in this case is positive 4. So I'm going up 4 over 1, up 4 over 1, up 4 over 1. And it just occurred to me, unfortunately, I did not make my graph very big for this one. So my scale's about to get a little bit off. I do apologize about that. Okay, if you're going to do that little sketch idea, you'd start here and you'd go up 4 over 1, up 4 over 1, until you finally get to 3, which is actually where this graph starts, and that should have a hole, so we don't have an equal to. And then you can start at 3 and then make sure that you erase everything up to 3. For those who would rather just figure out where 3 is and start there, you can take 3 and you can plug it in. 4 times 3 is 12, plus 1 is 13. And so you can plot your first point, or in this case your first hole, at 3, 13. And then you can go up 4 over 1, up 4 over 1. Again, there's not a right or wrong answer specifically. It's deciding which one you pick. Unfortunately for me to model this, like I said, I'm going to have to skew this scale because 13 is going to put me up in my work. And again, I'm sorry about that. So these are about to get pretty close. So 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and so my first point is going to be up here. And then up 4, 14, 15, 16, 17, over 1, puts me here. And then this keeps going all the way to infinity. Okay? And again, I'm sorry about the scale. Okay, composite functions, these are the last two that I created to start our review here. So go ahead and take a look at these two. Let's do this one first, f of g of x. Go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so here we go. This one's telling me I'm taking g of x and I'm plugging it into f. Now this one has a little bit of a tricky spot because look at where you are plugging this in. And this was the homework makeup problem for today as well. Okay, look at where you are plugging it in. If I took this negative 4 minus x and I plugged it in here, which is what I need to do, g of x is going to get plugged into f of x. Look at where it's located. It's located behind a minus. Meaning, as I keep this absolute value, as I keep the 5, as I keep the minus, and as I keep the plus 1, I need to make sure that this g of x, that all of the g of x is being subtracted. So what is minus negative 4? Plus 4. And what is minus negative x? Plus x. This composite function is 9 plus x, absolute value of 9 plus x, plus 1. Okay. Last one. Go ahead and pause the video, give this a shot, and then remember we are going to pick up and continue to do review on Wednesday. But give this one a shot and restart the video when you're ready. Okay, so this one, f of x, is getting plugged into g. Okay, and so thankfully in this one, notice where the x is. It's not behind a minus, so we're going to plug in just kind of free will. So we have 1/5 times 5 to the, and I'm plugging x plus 3 in, so x plus 3 minus 7 minus 4. Which is 1/5 times 5 to the x. 3 minus 7 is negative 4 minus 4. Okay, and there you go. Okay, we're going to pick up with this on Wednesday. Good luck studying. See you then.